C# and AI Masterclass by Edgar Milvis Volume 1, Chapter 3. Turning our attention to Chapter 3, Text Handling, Strings, Concatenation, and Interpolation. Now, let's explore theoretical foundations. Text in programming is the digital equivalent of human speech. Just as we use words to communicate ideas, programs use text to display messages, process user input, and format data. In C#, the primary tool for handling text is the string type. While we introduce string literals in Chapter 1, like "Hello, World," and used variables in Chapter 2, this section focuses on the theoretical foundations of how text actually works in memory and how to manipulate it effectively. Turning our attention to the nature of strings, immutability. To understand text handling, you must first understand that C# strings are immutable. This is a technical term that means once a string is created, it cannot be changed. Real-world analogy: imagine you write a sentence on a stone tablet with a chisel. Once the letters are carved, you cannot erase them or change a single letter without damaging the stone. If you want to change the sentence, you must find a new stone and carve a completely new sentence. In C#, every time you modify a string, you are not changing the original, you are creating a new stone, a new string in memory, with the new text. Why this matters: in Chapter 2, we learned about variables. A variable is like a label on a box. When we say string name equals Alice, we put the text Alice into a box labeled name. If we later try to modify name, which we cannot do directly to the string itself, C# creates a new box with the new text and updates the name label to point to that new box. The old box with Alice still exists until the system cleans it up. Now, let's explore building text, concatenation. The most fundamental way to combine text is through concatenation. In C#, we use the plus operator, which we learned in Chapter 2 for adding numbers. However, when used with strings, it joins them together. The mechanics: when you write "hello" plus "world," C# takes the characters from the first string and appends the characters of the second string to create a new string. Real-world analogy: think of two trains. Train A has cars labeled H, E, L, L, O. Train B has cars labeled W, O, R, L, D. Concatenation is the process of uncoupling train B and physically attaching its cars to the end of train A to create one long train. Code example, using only Chapter 1 and 2 concepts. Look at lines 4 through 6. Here, we're declaring two string variables, greeting and subject. We're initializing them directly with string literal values, hello, and world, respectively. This process of declaration and initialization is fundamental to storing data in a program. Notice how we use the string keyword to specify the data type. This tells the C# compiler that these variables will hold sequences of characters. Choosing the correct data type is vital for memory management and ensuring that operations performed on the variables are valid. If we tried to assign a number to a string, the compiler would flag an error, enforcing type safety. At line 8, we introduce a new string variable named fullMessage. The interesting part here is how we assign its value, greeting plus subject. This demonstrates string concatenation using the plus operator. In C#, when the plus operator is used with strings, it doesn't perform arithmetic addition, instead, it joins the strings together sequentially. The result of this operation will be a new string containing "Hello World." This is a very common operation in programming, used for building dynamic messages, file paths, or user interface elements. While simple, understanding how string concatenation works is essential for constructing meaningful text outputs. Finally, at line 11, we have console.writeLine, fullMessage. This is the instruction that actually displays our combined message to the console. Console is a static class from the system namespace, remember our using system directive? Its writeLine method is designed to output text to the standard output stream, which is typically your terminal or command prompt, and then append a new line character. This method is incredibly useful for debugging, providing user feedback, or simply showing the results of your program's execution. Without console.writeLine, our program would perform its operations silently, and we wouldn't see the outcome of our string manipulation. Output: Hello World. Edge case: handling spaces. A common beginner mistake is forgetting that concatenation does not automatically add spaces. If you want "Hello World," you must explicitly include the space. Here, at line 1, we're combining two string variables, greeting and subject, along with a space in between, to form a new string called message. This is a common operation in programming, string concatenation. We're essentially building a complete sentence or phrase from smaller parts. Then, at line 2, we use console.writeLine to display the content of our message variable to the console. This is how we provide output to the user in a console application. The comment on line 2 shows us the expected output, "Hello World." This simple example demonstrates fundamental string manipulation and output operations, which are crucial for any interactive program. Turning our attention to the evolution of formatting, string interpolation. While concatenation works, it becomes messy when you have many variables. Imagine trying to build a sentence with 5 different variables using 5 plus signs. It is hard to read and prone to errors, like forgetting spaces. C#6 introduced string interpolation, denoted by the $ symbol. This allows you to embed variables directly inside a string literal. Real-world analogy, think of a Mad Libs game or a form with blank fields. Instead of writing separate sentences and gluing them together, you have a template. My name is _________ and I am _______ years old. You simply fill in the blanks. String interpolation lets you put the variables directly into the blank spaces. Code example. At lines 3 and 4, we are declaring and initializing 2 variables, name of type string and age of type int. The string type is used to store sequences of characters, like text, and is a reference type in C#. The int type, short for integer, is a value type in C# and is used to store whole numbers. Notice the comment on line 4 referencing chapter 2, this is a hint that the concept of numeric types, and specifically int, would have been introduced earlier in a learning context. These variables will serve as the data we want to embed into our output strings, demonstrating how different types of data can be combined into a single text representation. Moving to lines 6 and 7, we encounter a traditional way of combining strings and variables, known as string concatenation. We create a new string old way by using the plus operator to join literal strings with the name and age variables. This method is straightforward but can become quite clunky and difficult to read, especially when you have many variables or complex expressions to embed. Imagine if you had 10 variables to include, the line would become very long and filled with plus signs and quotes, making it harder to quickly understand the final output string. This approach involves creating multiple intermediate string objects, which can have minor performance implications and highly performance-sensitive loops, though for simple cases like this, the impact is negligible. Now, at lines 9 and 10, we see a much more modern and preferred approach, string interpolation. We declare a new string new way using the $ prefix before the opening double quote. This $ tells the C# compiler that this string literal is an interpolated string. Inside an interpolated string, you can embed C# expressions directly within curly braces. Look at how name and age are placed directly within the string. This significantly improves readability and reduces the chances of errors compared to traditional concatenation, as you can see the final string structure much more clearly. It's often considered a best practice for constructing strings with variable data because it's cleaner and more intuitive. Finally, at lines 12 and 13, we use console.writeLine to display the contents of both old way and new way to the console. Console.writeLine is a method from the console class, which, as we discussed, is in the system namespace, that outputs a string to the standard output stream, typically your terminal or command prompt, followed by a new line character. By printing both strings, we can visually confirm that despite using different construction methods, both traditional concatenation and string interpolation produce the exact same output. This reinforces the idea that string interpolation is primarily a syntactic sugar feature, designed to make string construction more developer-friendly without changing the fundamental outcome. Output: my name is Alex and I am 25 years old. My name is Alex and I am 25 years old. Why this is better for AI and modern development: in AI applications, you often construct prompts or system messages dynamically. For example, you might need to send a query to an AI model, analyze the following text, user input. Return a summary. Using interpolation, $analyze. User input is far less error-prone than concatenation, analyze. Plus user input, especially when dealing with special characters or complex data structures, though we cannot use complex structures yet. Moving on to controlling text, escape characters. Sometimes, the text you want to write contains characters that have special meanings in C#. For example, the quotation mark is used to define the start and end of a string. What if you want to include a quotation mark inside the string? The concept, escape characters use a \\\\ to tell C#, treat the next character literally, not as a code command. Common escape sequences \\\ inserts a double quote. \n inserts a new line, moves the cursor to the next line. \t inserts a tab, creates indentation. Real-world analogy, think of a traffic cop directing cars. If the cop wants to say the word stop, they might shout it. But if they want to indicate a literal stop sign, the object, they might point at it. The \\ is the pointing gesture, it tells the computer, don't execute this, just display it. Code example. Here at lines 3 to 4, we have a commented out line that illustrates a common problem when working with string literals. If we were to uncomment this line, the compiler would report an error. The issue is the double quotes around hello. C# interprets the first double quote after said as the end of the string literal, leaving hello and the final double quote as unexpected tokens. This is a crucial concept for beginners. The compiler needs a clear way to distinguish between the delimiters of a string and characters that are part of the string's content. This scenario highlights the necessity of escape sequences, which we'll see next. Look at line 7. We declare a string variable named quote and assign it a value. Notice the use of backslash followed by a double quote, within the string. This is an escape sequence. The backslash tells the C# compiler, hey, the character immediately following me is not a special character for the compiler, it's part of the actual string content. In this case, backslash means, treat this as a literal double quote character, not as the end of the string. This is the correct way to embed double quotes within a double quoted string literal. Without this, the compiler would get confused, as explained in the previous example, leading to compilation errors. At line 10, we see another important escape sequence, \n. This sequence represents a new line character. When this string is printed to the console, \n will cause the output to move to the next line. This is incredibly useful for formatting text output, making it more readable by breaking it into multiple lines. Imagine trying to print a multi-paragraph message without \n, you'd have to use multiple console.writeLine calls, which can be less efficient and harder to manage for dynamic content. Using \n within a single string literal is often more concise and expressive for creating multi-line text. Finally, at lines 12 and 13, we use console.writeLine to display the contents of our quote and multiline variables to the console. Console.writeLine is a fundamental method in C# for outputting information. It automatically appends a new line character at the end of the output, so each call starts on a new line. When quote is printed, you'll see the literal double quotes because we used \. When multiline is printed, the \n will cause line 2 to appear on a separate line from line 1. This demonstrates the practical effect of the escape sequences we've discussed, making our string output behave exactly as intended. Output. This block of code, from lines 1 to 3, appears to be a simple text snippet rather than executable C# code. It seems like a placeholder or an example of plain text. In a real C# application, these lines would typically contain namespaces, class definitions, method implementations, or other C# language constructs. As it stands, this text would not compile or execute as C# code. This highlights the fundamental difference between plain text and structured programming language code, which requires specific syntax and semantics to be understood and processed by a compiler. A diagram showing a variable name on the left pointing to a memory address, which in turn points to a distinct object in the heap containing immutable text data. Now, let's talk about practical application in AI contexts. As a developer building AI applications, text handling is your primary interface. AI models, whether they are large language models, like GPT, or local models, like Llama, consume and produce text. 1. Prompt engineering. You rarely hard-code prompts. You usually build them based on user input or configuration. String interpolation is the standard for this. Example, string prompt equals $, translate the following English text to French. User input. If you used concatenation here, and user input was empty, you might accidentally create a prompt that says, translate the following English text to French, with a trailing space, which might confuse the model. Interpolation handles spacing more naturally. 2. Parsing responses. AI responses often come as JSON or structured text. While we haven't covered arrays or complex parsing yet, understanding how to find substrings, using methods we will learn later, and handling escape characters is vital. If an AI returns a quote inside a JSON string, it will look like \content \, he said hello \. Understanding escape characters allows you to display this correctly to the user. 3. Data cleaning. Before sending data to an AI model, you often need to clean it. This involves removing extra spaces or formatting. While we cannot write loops to process every character yet, the foundation of string immutability means you must understand that cleaning text always results in new text, never a modification of the original input. Turning our attention to theoretical foundations. Strings are immutable, you cannot change a string once created. Operations return new strings. Concatenation, plus the basic way to join text, useful for simple combinations but can become unreadable. String interpolation, the modern, readable way to embed variables into text. Essential for dynamic AI prompts. Escape characters, / the mechanism for including special characters, like quotes or new lines, within a string literal. These concepts form the bedrock of text manipulation in C#. Everything you build, from a simple console greeting to a complex AI chatbot, relies on your ability to effectively create and combine text. Let's discuss basic code example. Here is a simple code example demonstrating text handling using the allowed concepts. Turning our attention to code example, the personalized greeting. This example simulates a simple application that asks for a user's name and prints a personalized greeting. It demonstrates the difference between manual string concatenation and string interpolation. Here at lines 1 to 6, we're setting up the fundamental structure of our C# console application. The using system statement at line 1 is crucial because it imports the system namespace, which contains foundational classes and types that our program will rely on. For instance, the console class, which we'll use extensively for displaying output, resides in this namespace. Without importing system, we wouldn't be able to use console.writeLine directly. The class program block at line 3 defines our main application class, and the static void main method at line 5 is the entry point of our application. This means when you run the program, the code execution always begins inside this main method. It's the starting line for our entire application's logic. Now, let's look at lines 7 to 12. This section focuses on variable declaration and assignment. Notice how we're declaring name as a string type and age as an integer, type. Choosing the correct data type is fundamental in C# because it tells the compiler how much memory to allocate for the variable and what kind of operations can be performed on it. For example, string is used for text, while int is for whole numbers. If we tried to assign a number to name or text to age directly, the compiler would flag an error because of type mismatch. This strict typing helps prevent many common programming errors and makes our code more predictable and robust. We're also immediately assigning initial values, Alex to name and 25 to age. At lines 13 to 17, we're demonstrating a traditional way of combining strings and variables, known as string concatenation, using the plus operator. Observe how we have to explicitly add spaces within the string literals, like hello and you are, to ensure the output is readable. While this method works perfectly fine, it can become cumbersome and less readable when you have many variables or complex string structures. Imagine constructing a long sentence with many variables this way. It would be quite a chore to keep track of all the plus operators and ensure all spaces are correctly placed. This approach is older but still valid, and understanding it gives you a good foundation for how strings were handled before more modern features emerged. Moving on to lines 18 to 22, we introduce a more modern and highly recommended approach for combining strings and variables, string interpolation. Notice the $prefix before the opening double quote of the string literal at line 21. This $ tells the C# compiler that this is an interpolated string. Inside an interpolated string, we can directly embed variable names or even expressions within curly braces. This significantly improves readability and reduces the chances of errors compared to traditional concatenation. It's much cleaner to see hello, name, than hello, plus name plus exclamation point. This feature was introduced in C#6 and has become a standard best practice due to its elegance and efficiency in constructing dynamic strings. Now, let's explore lines 23 to 27, which deal with handling special characters within strings, specifically using escape characters. Look at line 26, console.writeLine, she said, \hello, \. The \/ character is an escape character. When C# encounters a \ followed by another character, it interprets the combination as a special instruction rather than a literal character. In this case, \ tells the compiler, don't interpret the next double quote as the end of the string, instead, treat it as a literal double quote that should be part of the string's content. Without the backslashes, the compiler would think the string ends after, she said, leading to a syntax error. This mechanism is essential for including characters that have special meaning in C#, such as double quotes, backslashes themselves, \\, new lines, \n, or tabs, \t, directly within your string literals. Finally, at lines 28 to 31, we demonstrate the power of combining string interpolation with escape characters. Observe line 30, console.writeLine, she said, \hello, name, \. Here, we have the best of both worlds. We're using string interpolation, thanks to the $prefix, to easily embed the name variable, and we're also using the escape character \, to include literal double quotes within our interpolated string. This shows C#'s flexibility and how modern features can be layered to create highly expressive and readable code for complex string formatting needs. This combined approach is very common in real-world applications where you need both dynamic content and precise control over special characters in your output. Thank you for your attention. This lesson is excerpted from Volume 1 of the C# and AI Masterclass, Chapter 3 of the ebook The C# Foundations, Syntax, Type System, and Logic for Modern Developers. You can find all the details here, https://github.com/edgarmilvis/C# programming series. The ebook also includes 25 chapters with diagrams, advanced examples, and 5 exercises with solutions. Subscribe to the channel to watch more videos. I look forward to seeing you in the next lesson.